Tommy Ansel, and I'm a senior finance major at Cedarville. I worked on this next deal along with Matt Julian and our angel investor mentor, Dave Grauer. Soteria Battery Innovation Group is offering Series A participating preferred shares totaling $3 million for a 12.4% equity stake in the company. They have a pre-money valuation of $12.5 million, and $850,000 of that is available for investment. Soteria has created safe lithium-ion batteries that nearly eliminate the risk of self-ignition or thermal runaway. Soteria has brought many large companies into its consortium, and in the future, Soteria plans to license its safe lithium-ion battery technology and charge recurring royalties. Today, we have Brian Morin. He is the CEO and founder of Soteria. He received his PhD in physics from Ohio State and has over 200 patents and applications. Thank you for joining the call today, Brian. The call is yours.
Great. Thank you, everybody. And while I share my screen, first, just a very impressive way you guys are doing things. Having an angel group open in prayer is a very refreshing change from some of the others who have a different focus. So I really like what you guys are doing. So let me share my screen and, okay. So my name is Brian Morin. I am the CEO and co-founder, sorry, things are setting up. CEO and co-founder of Soteria Battery Innovation Group. We are dedicated to safety in lithium-ion batteries. It's our belief that as batteries become pervasive throughout the world, that the battery fires are going to take lives. And we are here to try to save as many as we can by making our technology pervasive throughout the battery industry. Soteria is the Greek word for safety. It's also the word in the New Testament for salvation, and it gives you a little bit of an idea of the motivation, right? That we've got a company that God's formed and we're the stewards of. So 2 things you need to know about us. Sorry, get to the right slide. There we go. First is we have a technology that basically eliminates lithium-ion battery fires caused by anything other than, taking a match and lighting it on fire. So mechanical damage, electrical short circuits won't set the battery on fire. The other thing to know about us is that we're bringing this to market in a Bluetooth-like consortium. We have 80 members today, including NASA, Mercedes, Bosch, Motorola, Applied Materials, DuPont, Rimac, which is one of my favorites. They have about a $500,000 electric supercar, and we've told them they can pay their consortium fees in automobiles if they'd like. That's a joke. It's all you get out of a physicist. The business model, we're combining kind of 2 models. So the first is we take our technology, put it out to the consortium as an open innovation platform. So think the Microsoft IBM PC platform, where all of these companies are now developing the software and disk drives and printers that need to be used with our technology, as well as developing the components and the ways to use our technology. So that's the open innovation platform. The beauty is the hard work is being done by our consortium members, who are the best in the world at what they do. So then our route to market is to set up a supply chain that's acceptable for the battery, electronics, and automotive industry by licensing the technology to advanced materials companies. Think DuPont and Teijin sitting in Mercedes' supply chain, not a startup trying to provide a critical component. We've sold 1 license, and we have 10 consortium members who are scaling our technology on their manufacturing plants in order to become licensees. The next 2, we're going to, because our cells will pass safety tests that every cell made today will fail, we're going to set an uncompromising safety standard that really differentiates between today's batteries and the safe batteries, which I'll show you in just a minute. And then for the companies that can certify their cells to that battery, and for the companies who use those certified cells in their devices, we're going to allow them to use the Soteria name and the Soteria mark as the sticker on the outside that tells you that the batteries on the inside are the safe ones. So the easiest way to demonstrate our technology is to show you it in action. I'm going to show you 3 different tests. The first is a overcharge test. So if you've ever heard about a battery sitting there on charge and just catching fire spontaneously, this is what happens. Lithium dendrites form inside the cell. They allow the cell to generate heat. that evaporates the electrolyte. And here both things are happening, but the failure mode is very different between the control cell on the left and our cell on the right. The left turns into basically a flamethrower, jet engine, whatever analogy you want. And then this is a nail penetration test, same result. This mimics physical damage to the cell. We get a very similar result under a crush test. But the difference is not only does our cell survive the test, but it continues to function just as it did before the damage. And now I'll give you that as a demonstration. It's almost a gimmick to light an LED with a battery that's been damaged because it just doesn't take much current to do so. It's absolutely not a gimmick to lift a drone off the ground. This is a 15 amp application, 15 amp draw out of those small batteries. And these guys are obviously not worried about driving a nail through a cell. We've done this hundreds of times. We've never had a failure with our materials. It always fails with the existing materials. And so now you've got 3 cells on the battery here, or on the drone here. You can see the nail on the left. You can see the nail sticking out of it here. And like I said, this is absolutely not a gimmick to be able to pull this much current out of a damaged cell. And you can think of lots of situations where you'd want your devices to keep working. So think military, think anything that's in the sky, anything that's on water or underwater. Functioning after damage is a key safety component, not just surviving the damage, but functioning afterwards. And this is the only way to do this. There's no other technology that delivers our level of function after damage. In fact, nobody even talks about that. They talk about surviving damage. Nobody even talks about the battery continuing to work afterwards. So 90-second science lesson. Every lithium-ion battery has 5 components: aluminum and copper foils, the electrode materials, the anode and the cathode materials coated on the foils, and then a plastic membrane in the middle. The foils bring the electricity in and out. The ions pass back and forth through the membrane from the anode to the cathode. Every lithium-ion battery fire starts when something punctures or damages that membrane. The energy of the battery flows through it and generates heat. That heat causes the membrane to shrink, which generates a bigger hole with more energy, more heat, and this becomes the spark that lights the battery on fire. We're going to do 2 things different. The first is we replace that plastic membrane with a nanofiber-based non-woven separator. We start with textile-grade fibers, inexpensive raw material, fibrillate them to nanofibers in a paper-making process. It's water-based, no impact on the environment. And then we feed those into a paper machine to make our thin uniform sheet. They're reinforced with Kevlar, which is stable to 500 degrees Celsius. So this nanofiber-based separator is never going to melt or shrink. The other thing we change is we replace the aluminum and copper foils with metallized film. So a thin sheet of plastic with enough metal on each side to run the battery. Think a potato chip bag or a party balloon. Now, when you get something that damages or punctures the membrane, the energy flows in briefly. The separator may char if there's some heat, but it won't melt or shrink. And now those intense currents cause the thin metal of the current collector to burn out like a fuse. It stops the flow of energy, and you have a working cell with a dead spot right around where the damage spot is or where the fuse is. And that's what you saw in the videos, is that we damage it. This technology isolates the damage from the rest of the battery. The rest of the battery keeps working, and you have a functioning cell that's made it through the damage or the manufacturing defect or the other things. And I'll say right now there are 3 electric vehicle recalls going on: Hyundai, General Motors, and BMW, because of electric vehicle battery fires. So this is an important problem. So 3 pieces to our value proposition. The first is the revolutionary safety, that we eliminate the root cause of thermal runaway and the cells continue to function after they're damaged. The next piece is important in that we do this without requiring the cell maker or the end user to suffer through any sort of a compromise. So because we get there by taking metal out of the battery, there's between a 20 and 30% weight reduction at the pack level in the device. There is lower material costs. Essentially, that copper is expensive, and we make 10 times as many batteries with the same amount of copper that the other guys, the current technology, uses to make one. Our inert components are a drop into all lithium-ion battery chemistries, all lithium-ion battery form factors, sizes, and shapes, and the manufacturing processes. So they just take the one that looks like a roll of aluminum foil, bring it to where they would process the aluminum foil and use it in the same way. And then we deliver the same or very similar electrical performance to what they have today and expect. So there really are no compromises. And then the last pillar is the industry support that I mentioned with a open innovation consortium, lots of work going on to implement our platform. And then the other piece is the broad and robust supply chain, that nobody's stuck with a sole supplier. We're going to have a broad supply chain. I mentioned weight reduction. We took apart a Samsung Galaxy Note 7 cell, measured all the components on the inside. These components make up about 25% of the weight of the cell. When you replace them with the Soteria components, the weight of the cell, this particular cell, comes down by 19%, and our components go from 25% to 8%. You can see especially that big copper sliver goes from 14 to 3. Similarly, the costs are driven down. The impact on cost isn't as high because the cost of these components is only 16%. But the good news is that the cost goes down, not up. So we expect our component cost in large volume to go down by between 20 and 40%. And the beauty is that we're having a major impact on the performance of the cell by affecting lower cost items. So even if somebody made a premium product, it wouldn't increase the cost of the cell by very much. We do have competition. Today, people are providing safety by taking the unsafe cells and putting them into steel boxes. Every Tesla has a titanium plate underneath it to protect the cells. And there's a lot of complexity. It amounts to a 30% weight and cost burden on top of the cells to accommodate the unsafe cells that are used today. Solid state batteries are not ready for full production. The best people are doing are very small cells in very small quantities. They're not compatible with existing manufacturing. So it's going to be a long time before we have solid state. Although there's a lot of money being invested, and I do hope they're successful. I think there's just going to be a large market opportunity for us, even if they are successful. And then non-burning electrolytes, people are working on it. There's a significant electrical degradation of the cell when you use the non-burning electrolytes. They don't give the same performance. We have 2 large patent portfolios, new patents issuing almost every month, and then covering both the separator and the current collector. The materials are industry ready. You see the companies in the middle are making these materials now at full scale and at very high quality. Production rates are about 0.5 ton an hour, so about 2 hours to make a ton of material. And then our launch in the market, we're going to have our biggest impact in electric vehicles, but the right place to start is critical environments where they have to have safety, where the standard of safety is really perfection. And so think a first responder handset. If somebody's in the middle of a fire, they don't need their handset to stop working because it got too hot. An electric vehicle that's down in a mine, oxygen is a scarce resource down there, so that they need to use it, not use it burning up their escape means. Soldiers, and then anything going through the air, but especially delivery drones, they're not allowed to drop those, and especially in flames, on uninvolved people. We're going to do these markets starting now, but then in 2021, and transition to the adjacent mass markets in 2022. This is our, didn't switch, there we go. This is our consortium spread out throughout the supply chain. And 2 things to notice. One is that we're very well represented throughout the supply chain, from the equipment raw material producers on the left to the end users on the right. The other thing to notice is there's giant people who are missing. So we think we only have about 1% of the potential companies in the consortium now. So our 80 could easily grow to 800 or 1,000, given a couple of years to do so. We'll get our royalties from one segment, and that is the paper manufacturers and the metallizers. Everybody else doesn't have to sign an agreement with us. They just have to buy the materials from these guys. So they see them either as a customer or as a supplier, depending on where they are on the supply chain. Our business model has 3 sources of revenue. The first is membership fees. Everybody on the previous page is paying membership fees. It was $200,000 in 2018, $480,000 in 2019, and going to be over $600,000 this year. And then the next two pieces are associated with the membership. We set up our membership. I said earlier, we want everybody to have the opportunity to have access to safe batteries. So we set up our licenses with a low ongoing royalty rate, but to make sure that people are taking it seriously, we set up a meaningful upfront fee. So you can see in the chart on the right, the long-term returns come from that ongoing royalty, the gray part of the bar graph. But we can get to cash flow positive on the other two sources of revenue. We're hoping to be cash flow positive in 2022 or by the end of the year next year, based just on membership fees. Exits, the first thing for us is to get profitable quickly, use the resources that we're given, steward the resources in the right way. And then once we're profitable, there's several exit opportunities. The beauty of this business model is that many companies that could acquire us are already engaged with the technology platform, already seeing the benefits, and have something in their business that could be leveraged against our business model, whether it's increasing a raw material sales like Kevlar or equipment like we would get from Applied Materials. And so our preferred exit is to stay independent and do an IPO. But my guess is that somebody will show up with a check before we get there that's too nice to walk away from. Obvious social and environmental impact, increasing the safety, promoting electric vehicles, solar and wind. The part that people don't think about that's also unique to us is the impact on the environment through the reduction of the metal usage. We have a great management team. All of us have advanced degrees. All of us have experience in large companies and at a C level in small companies. And Jean Lee represents us in China, and Jürgen does in Europe. Our advisory board, we meet twice a quarter, and so very active. Sun Ho, Brad, and John are all senior executives in lithium-ion batteries for more than 10 years, and Randy was a direct report to Jack Welch and has been CEO of 3 different billion-dollar companies. We've won a number of different awards. Most recently, we were named the #1 battery company and #1 overall in the New Energy Challengers. And then I'll close with the terms of the round. We had to increase the size of the round. It was oversubscribed at $2.25 million, so we've increased it to $3 million. And it's participating preferred shares with a pre-money valuation of $12.5 million. And this group, we're giving second tranche coverage, even though the second tranche is finished, which has 20% warrant coverage. We are closing the round on November 15th. So the board has asked me to go back to running the business rather than raising money. And with that, I will stop and take questions.
Thank you, Brian. All right, so if y'all just want to continue to send in your questions, we have quite a few to get started here. So first off, Brian, could you explain the relationship between Soteria and Dreamweaver?
Yeah, sure. So Soteria is really a pivot from Dreamweaver. In Dreamweaver, we had the separator technology, and we were contract manufacturing it and trying to be direct sellers to the large battery companies. They liked the technology, and we placed it in several different batteries, but it was only small applications. People weren't willing, big companies and primarily Asian companies weren't willing to put us into as a major component in significant parts, in significant products. So Dreamweaver was turned into a holding company, which owns the separator technology. We started Soteria from scratch. Soteria has the exclusive right to sell the licenses to the Dreamweaver technology. And we own the current collector technology outright. We share the royalties with Dreamweaver between 30 and 50%. So we keep between 30 and 50%.
Okay. For next question, could you talk about the market adoption risks and what you're doing to mitigate those risks?
Yeah, and that's real. The easiest thing for our customers to do is to keep doing next year what they did last year. So we're starting in environments and applications where safety is really the most critical design parameter, and I mentioned what those are. And those guys really, they can't walk past a safety opportunity, and so they have to implement. They will then become the reference points for the mass market. So once Motorola is using it in their handsets for first responders, it's pretty easy for a cell phone producer to say, okay, those guys have done it. It works. It's less expensive, lighter weight, and safer, so they can adopt it also. So we're starting in the areas where they just can't walk past it.
Great. Do Soteria batteries have similar life per charge and total life as their existing counterparts?
Yeah, and in fact, so the capacity of the cell doesn't change at all. The weight normalized capacity, which is what people usually think about, goes up because the weight goes down. And then the cycle life is equal or better. The Dreamweaver separator, it turns out, will absorb some of the degradation products of the electrolyte and keep them from continuing to degrade, which gives us a longer cycle life when the Dreamweaver separator is used.
Okay. So what new specific relationships are you counting on in order to scale in 2023 to 2025?
Yeah, so the first thing is, between now and then, we need to get some of our potential licensee consortium members out into the markets with the products that they've developed. We just had a review last week. Those guys are doing a great job developing new versions of our products that are better than we would have done on our own. But we've got to get them to take the bite and get out to market. And then the question in my mind, so I think the first answer is, let's execute along what I said, which is get into the critical markets, get into the adjacent consumer markets. And the big question in that time frame is, when do we start a full engagement with the automotive industry? We've got 3 consortium members who are automotive focused now: Mercedes, Rimac, and S-Volt. But when do we really start focusing on that segment? Because it takes a long time to develop, but that's the right time frame, right?
Another question is, what prevents a company like Tesla from reverse engineering your technology?
Well, and so certainly they can reverse engineer it. The royalty rates are relatively low, and we provide enough know-how that it's probably not worth it to them. So people ask me, the other question is, what if a company, reverse engineers and goes and cheats? I mean, we have our patent portfolio to fall back on. We wouldn't try to prevent a company like Tesla from using our technology. Rather, we just want to make sure they pay the appropriate royalties. It amounts to about $50 on call it a $50,000 Tesla. So, it's almost de minimis for them. And then we believe that in time, the Soteria name will also have an impact, that they can put a label on the outside saying, hey, we've got the safe cells on the inside.
Great. So kind of going a little bit along with that, could you also talk a little bit more briefly about your competitors?
Yeah, so there are some manufacturers of thermally stable separators. They're having an impact on the market. The technologies that are out there now are heavier and more expensive, but otherwise functioning well. There's one technology for a safe current collector. It's a coating that goes on the current collector, so it's also heavier and more expensive, rather than being lighter and less expensive. So, and then the thing to say is, anything that helps safety in lithium-ion batteries, we consider our friends. So this is the love your enemies piece. We're going to let them use the Soteria name if their cells can pass the test. And our goal is to get ourselves to have 25% of the industry 10 years from now, so our materials, but to raise 100% of the industry to our safety level, the other 75 coming from competitors. We want them to succeed.
All right, so you have time for a few more questions if y'all want to send some more in. Let's see, here we go. What is your expected penetration into aircraft manufacturing?
So it's an interesting question. So I honestly believe that we will be 100% penetrated into electric aircraft. There are air taxis, drones, even short haul aircraft that could make a hop from where I sit, let's say from here in Charlotte to Columbus, Ohio. That could be done on a electric aircraft within a few years, right? Those are flying now. And I don't think they can walk past the weight and safety value proposition that we've got. The rest of the aircraft industry, I think, will adopt us also. But the number of batteries in an electric aircraft is gargantuan. One of our customers, lightly commented that basically it's a battery with an airplane painted on the outside, right? So.
And then lastly, kind of goes along with this, what industries do you believe would be the first adopters or early adopters of Soteria's technology?
First adopters are going to be the nimble companies in the markets that I said, but think anything that's a critical environment, anything where if the battery catches fire, they don't have a way out. So if it's floating on the water, if it's underwater, if it's in the sky, if it's underground, if it's in the middle of a forest fire, those people cannot afford a battery fire. They can't walk past even a single, right? They can't walk past any safety applications. So soldiers fit in there. The military just this year wrote a specification that requires very high energy density and to pass a nail penetration test for the batteries that the soldiers carry. And honestly, we have 5 or 6 companies who are addressing that and telling us that we're the only way they can get safety with their technology. So I owe a thank you to a general somewhere. I don't know where he is, but they wrote us in. They didn't write us in. They wrote in our performance.
All right, let's see. You've got time for 1 or 2 more. Do you anticipate regulatory pressures to force adoption of your technologies in some areas?
I do. Our model, and this is long term, is first set the standard, get voluntary adoption because of the brand. But then what I expect is the FAA at some point is going to say, okay, by 2025, all cells that are all portable electronics devices that can get carried onto an airplane have to have cells in it that pass this test. I expect the NHTSA to do the same thing for highways, right? We all have airbags because they did. We all have anti-lock brakes. We all have rear view cameras. I think all electric vehicles are going to have cells that are required to pass this test. The reason they don't require it today is not because they don't want to, it's because the cells won't pass.
Okay. Well, thank you, Brian. I think this concludes our time for Q&A, but I really appreciate you taking time to pitch to our investors and for answering all the questions. For everyone else on the call, this will conclude our Q&A session and this portion of the call.